So for this week on CyberSchool, we're going to be discussing SIP transport protocols, which are UDP, TCP, and TLS. Those are the three main different transports that will be used when you're dealing with SIP. And we'll spend a little bit of time talking about each one and their advantages. We've been getting a lot of questions about the different transport protocols now that we've added support for multiple different SIP transport protocols and which one is best for the right environment and what are just the differences between them. So I figured this would be a great occasion to talk about what they are, what those little abbreviations mean, and how they affect your devices. And I figure why we're in here talking about SIP transport protocols and especially TLS, we'll also cover RTP and Srtp because those really just kind of go hand in hand. So to start, what is SIP transport? First, we need to know what SIP is before we can understand what SIP transport is. And SIP is Session Initiation Protocol. And basically what that is they're messages that are set as a standard that are used to start media transport between one device and another. When it was defined, it was used as a way to start a session of media from basically a sender to a receiver. And it was, potentially bi-directional. But where this is typically used is in VoIP, where the majority of phones that you get today are SIP-enabled devices, where they will send and receive different SIP messages to either initiate or receive calls. There are other protocols that are out there in terms of setting up VoIP calls. But for the main purpose of what we'll be discussing today is SIP transport. There are others out there, and these kind of ideas that we'll discuss today really cover the majority of any type of protocol that would be used by a computer. What we'll discuss today doesn't necessarily have to be restricted to only SIP, but it does apply to SIP. So of course, SIP is the most common protocol that's used in calls to set up VoIP calls. It's basically just a way, again, for one device. Say if you pick up your phone and you want to call your boss because you got to tell him something, your phone will send an invite to them to initiate a call. And the same thing works with, say, our products with our intercoms. When you press the call button and they make a call to that predetermined number, they're doing all of that with SIP. There's three different ways to send these SIP messages, which we'll be discussing at length today, which are either UDP, TCP, and TLS. And each of these three different transport protocols have their own advantages and disadvantages. Really, there's two main protocols. There's UDP and TCP, where TLS is basically just encrypted TCP, but we'll cover them in kind of all three potential scenarios because they have different use cases and different applications. So now that we know a little bit more about what SIP is and what we'll be talking about today, let's get into UDP. So UDP is, of course, going to be the most common protocol that's going to be used across the internet in general, but also in VoIP. And UDP stands for User Datagram Protocol. And basically what that is, it's a different way of sending messages. This is just, basically all we're going to be talking about today is getting the message, whether it's, an HTTP post command to pull up a website or to make a change on a website, say if you're doing something on Facebook or Twitter, Instagram, what have you, or if you're trying to set up calls, we'll be talking about the transport methods. And that's one of the ones where UDP comes in. And this has kind of been the standard for SIP transport protocols since SIP was started in the late 90s. It was kind of the basic way to be able to send data because of the way that it was built. It was one of the first ways that it was to actually go and send the traffic. It's a very, very basic way to send the traffic. But as such, since it was created, it was one of the first protocols. It's not refined in nice ways that you'll get with, say, newer protocols or newer transport methods. But with UDP, all data is basically sent without guarantee of being received, which sounds a little strange, but if you're building something with the ground up with knowing that you have no idea what you send will get to the end destination, you can build in ways to ensure that that will not be a problem. The common ways to think about a lot of these different protocols are different ways that, say, mail or packages will get delivered. A lot of us, especially, in the current times, have been getting packages delivered, and we deal with, different types of package carriers. Sometimes you'll get, basically a package, and you have an idea it's coming, and then it just shows up at your door, and you have no idea that it gets there. And the sender really doesn't have that much of an idea if it actually got where it was supposed to get, because it takes, hours to update the tracking number. It can take, upwards of an hour or 2 hours after something's delivered for the tracking to actually show up in the history. And that's very similar with UDP. UDP is essentially like sending a package, but not knowing that it gets there. It's designed that way so there's basically failovers that'll occur, and it will send multiple of the same messages in case that there isn't an acknowledgement that's sent in response to the message being received. The way that the protocol was designed to be used by other protocols, because it's a transport protocol, it basically allows the protocols that will use this transport to build in different ways to understand that either message was received or it was not received. And the idea that with kind of focusing on SIP, the easiest way to understand that and how this works is how a typical SIP message, a SIP call will work. So, for example, talking about one of our SIP intercoms, when the front call button is pressed of the intercom, it's going to call that predetermined number. And basically what it'll do is it'll take that extension number from the dial out extension field and send a request, an invite request, to the extension number at the SIP server address that it's sending to. And it will send that message, and the server will respond with what's known as 100 trying. And that basically just says message received. Now, that's a different message. It's not, for example, and we'll cover this a little bit later, sending the message and then the device confirming, I have received message 1. It is saying, I got your message, let's move forward to the next step, instead of an acknowledgement just merely saying, I have received your message. It's let's move on to the next step. And then the server, in this instance, after sending the 100 trying, will then send what's known as a 180 ringing, where they move to the ringing state. And at that point, the physical device that our intercom is calling, say a desk phone, starts ringing. And we all know the sound of a ringing phone, and that basically the device will sit at that point until something occurs. The CyberData device at that point doesn't need to do anything. It can just sit there and wait for the call to be received. If, for example, the ringback tone is enabled, the device will play a tone to let the user at the intercom know that the device is ringing, but it can just sit there. And then if somebody comes over and answers that particular desk phone that's ringing, the desk phone will then answer with a 200 OK that will then go to our intercom, and our intercom will answer with literally what's known as an acknowledgement. It's called an ACK message that says, we have received the 200 OK and we are going to start the call. So with UDP, they build in redundancy to compensate for this no delivery guarantee. Instead of being able to send one message and say, okay, I have received message 1, send me message 2, it is just, I'm going to send message 1 and hopefully it's going to get there. Now, some of the problems that come up with this is, of course, there's no guarantee of what's being delivered, so you want to use UDP with kind of unimportant stuff. For example, a lot of video streaming in the early days of YouTube and, back even on, say, Netscape and very old real player video days, all of the video would be sent over UDP because it would be expected by some people, and, not as much today. We're a little bit more... We expect no frame drops today, but back then, if you would get some stutters or a frame drop in a video that you were watching, that would be acceptable because you just understood that kind of stuff would occur. You're dealing with, a streaming video, it's new, so there can be those limitations of a frame drop, which are the symptoms of using UDP and a message not getting to the end destination. Say if you're sending a video and say you're sending 30 frames a second and you miss, 15 frames, you're going to get some cuts in that particular second of video, and it'll be noticeable to the person, but will be acceptable based on what's going on and the current speed at the time. It's a really simple solution, but it's also insecure because with UDP, nothing is encrypted. So if you're sending anything via UDP, hopefully you're not too concerned about what you're sending, because it's very easy to intercept the messages and be able to spy and see what's going on with them. So then after UDP, we kind of evolve into TCP, which is Transmission Control Protocol. This is probably the second most common protocol that's used across the internet. Really, UDP and TCP are really competing. TCP is becoming a lot more popular and is very soon going to overtake UDP in just general use on the internet. But TCP is very, very popular, and especially becoming more popular in VoIP. This one, instead of being built with not having delivery confirmation in mind, TCP is built from the ground up, knowing that if you send message 1, whoever receives message 1 will let you know, I have received message 1, I am ready for message 2. So when you use TCP, you have a guarantee that any data you send will make it to the destination. And for example, if you send that message 1 and it doesn't make it, you will stop and you will not send message 2 until you send message 1 and you get an acknowledgement that message 1 was received. So it makes it very, very it's an easy way to ensure that whatever data you're sending will make it to the end destination and will be there without a problem. So it's really useful now for, say, video streaming, where now with everybody having, very fast computers and fast internet as comparison to, late 90s, early 2000, we don't really accept stutters or problems with buffering and low frame rate as much as we would back then. Where now if you're watching a YouTube video and you get that little buffering wheel in there, that's not good. You're not happy with that. Or if you get frame skips and you're watching something, you won't be acceptable of that. And that's one of the reasons that they've switched to TCP, where it's not as common anymore to get a lot of those frame drops. It still occurs, but it won't you won't actually miss frames where something will be happening and then you'll miss, say 2 or 3 seconds of footage where the footage will stop and you'll get that nice little buffering wheel, and then it will continue when it has enough buffered data received. So with TCP, it's a little bit more practical, because anything that you send will make it to the end destination. And how this is used in VoIP is because of the different connection style. With UDP, you're basically sending whatever data you get as fast as you can, and you're not really concerned if it gets there. You hope it gets there, but if it doesn't get there, you're not going to hang up. Where with TCP, you will hang up and you'll pause if that data hasn't been received, and you'll keep trying to send that. So with VoIP and using TCP, the devices actually make a connection to each other before they start sending the data, so that way they know, hey, a point A can talk to point B. So in that same scenario, when we were talking about just the standard SIP outdoor intercom, you press the button and it calls that predetermined phone number, and you're calling a desk phone to call your boss. There's going to be a connection between the two devices, and if you're dealing with something, say, and this is something that we encounter a lot with a lot of different hosted providers, is problems with firewalls, where certain ports won't be enabled, or it'll be tough to get traffic through if you're using UDP, where the traffic will get out but it won't come back in because it's to the ideas of the firewall and whatever's running that unsolicited traffic. Where if you're dealing with TCP, you make that connection first and then the traffic is sent between the two devices. So it makes it easy to bypass some simple firewall related problems, which is why we recommend a lot of customers, especially in our support department, if they're, say, using RingCentral or AT&T Office at Hand or other hosted providers that do support TCP and they're having some registration problems, it's just not working, all their credentials look right, but they just can't get the blasted thing to register, switch over to TCP. If you might be having a firewall related issue, and switching over to TCP because of the connection style difference, again, meaning that point A and point B connect to each other and then start sending the data, it works a little bit better and can bypass the firewall related problems, because the firewall understands that something internally to that firewall, again, firewalls block traffic from the outside world coming in, not from the inside going to the outside world. the firewall will know, hey, I've got a device on the inside that's trying to get this traffic. I need to let this traffic through. So that's one of the reasons that TCP can be really useful in VoIP, and it's becoming more popular because of that, because it's really practical and useful when you're dealing in a hosted environment because of those firewalls and those network problems, especially when you're dealing with, say, a smaller deployment where you might not have a network guy on hand that can kind of go through and work through all these problems and understands the complexity of firewalls. TCP can be a great solution as just kind of a turnkey option. Okay, UDP is not working. Let me change 2 settings and see if TCP works. It's a really easy option to potentially get around some initial headaches and problems that might be introduced just based on how the network is currently configured. And finally, we get to TLS, which is Transport Layer Security, most commonly known as TLS. And all this is encrypted TCP. It's typically referred to as a separate transport protocol, and it kind of is, but it's kind of not, because it's just security built on TCP, hence encrypted TCP. It's really cool, and there's basically, you've either got the completely unencrypted, I don't care if it gets there UDP, you've got a little bit more concerned, I hope it gets there, but it's still unencrypted TCP, and then you've got, I want it to get there, and I don't want anybody to know what is in here. So it's a really, really good way to be able to send traffic across the open internet, and it's becoming very, very popular as a lot of people, especially in our current times, are moving to doing a lot more of their stuff in the cloud. Whether it's things like Office, Microsoft Office or Office 365 being hosted in the cloud, a lot of your phone providers being hosted in the cloud. This encryption of data is super important if anything's going across the internet. And you get that nice guaranteed delivery built into the protocol from the ground up. Whereas with other options, with something that we won't really cover today, but it's known as secure UDP, it's basically secure UDP, where you don't really care if it gets there, but you don't want anybody that might receive it that isn't supposed to be able to read it. That one's not really as practical and not really used in VoIP. So when you're dealing with any kind of security in mind, when you're dealing with SIP calls, you're going to be using TLS. Now, TLS, there's been multiple different iterations of this particular protocol because it's been around for a really long time. It started with version 1.0, which was, very old and very depreciated, but was good for the time, in the late 80s, 90s, and even the late 90s. It was very powerful. Everybody was using TLS 1.0. But as more people started getting home computers and internet connections and speeds got a little bit faster, people were able to actually crack the cipher suites that are built into TLS. And basically what that means is when any of your devices are going to be sending traffic using TLS, it'll take just the raw traffic that is, basically readable by your computer and, by you, depending on what programs you're using to look at the traffic. It will take that traffic and run it through what's known as a cipher suite, basically a way to encrypt it. Your decoder rings that you used to get from your boxes of cereal as a kid. Basically run it through one of those. And when you go and set up one of these TLS connections, we'll refer back to that, initial scenario of just pressing the call button on an intercom and calling a predetermined number. When the two devices connect using TCP to say, hey, I want to call you. Are you available for a call? And then both devices will say, yeah, I'm ready for a call. But they'll also exchange basically decoder ring keys to be able to say, I'm going to send you encrypted messages using this key. So now you can decrypt my messages. And they both say, okay. And they start that whole transport, SIP transport process where they send they send the invite, the 100 trying, the 180 ringing. That process still all goes, but it's all encrypted. So only the person sending the call and the person receiving the call know what's actually in the message. If, say, somebody were to go in there and spy and receive that traffic, they just see a whole bunch of gibberish because everything's encrypted. So it makes it really secure. But the problems occurred with TLS 1.0 and 1.1. People were basically able to break the code on those decoder rings. They were pretty cheap ones. You got them from a box of Cracker Jacks, and they weren't really good decoder rings. You needed a better decoder ring. So that's why they've evolved through the different iterations of the protocol up to TLS 1.2, which part of it has been cracked today. It's still the current standard because it's even though it's kind of been cracked, it's really hard to crack. It doesn't mean it's easy to crack. It's been cracked, but you're dealing with like quantum computers. You're dealing with like NASA can crack it, but like the regular person, they can't really crack it. So TLS 1.3 is coming and will be a standard, at some time in our the 2020s here. But for the time being, the current standard is TLS 1.2. And all these updates did was just remove vulnerabilities and improve the cipher suites as they went. As they started with version 1.0, yeah, the cipher suites got broken, but then they also found these potential flaws in the code. So that they improved on those and removed those flaws and vulnerabilities, as well as improving the cipher suites. And when they improve the cipher suites, they're doing anything from completely changing out the type of cipher suite that was used, meaning it was, basically swapping complete different decoder rings. They just completely, that decoder ring is trash. I'm going to get one instead of from Cracker Jacks, you're getting it from your Cheerios. You're getting it from a different cereal box, essentially. Then they improved on it and saying, okay, this really small decoder ring that takes an A and turns it to a B, that's not very good. I need something that jumps it a little bit farther and makes it bigger. So what they did is instead of making it, say, a 256-bit key, they made it a 1024-bit key. So they go and change the different number of variables that are in there with the key to just go and make it a little bit more secure. So that is basically what TLS is and that type of encryption, and it's becoming a lot more popular in VoIP, just because, again, everybody's moving to hosted providers. They're either dealing with Zoom, RingCentral, NetSapiens. As everybody is moving to having their phone system in the cloud, they want to be able to encrypt that traffic as it goes through the cloud. But there's vulnerabilities with TLS, but probably not with what you're thinking. Oh, wrong button. So which protocol is going to be right for the particular situation? You're trying to spec and figure out, okay, I'm getting this new phone system. Which transport protocol is right? Well, it's kind of a complicated answer, and the easiest way to put it is it depends. So there's a couple different factors that can help you decide which particular protocol is right for the situation. So number one, of course, is being, is it hosted in the cloud or is it going to be on-premise at the physical location? Because those are going to have different security requirements. If something's going to be, say, going through, a missile silo for, the government, that's going to be pretty secure, and they might not need to have that local network security enabled because nobody's going to get on their network. So what's sent on the network doesn't necessarily need to be encrypted. Whereas, if you're working from home and you're dealing with, very secure business plans or something, $1 million deals, and you're talking about that and setting up calls for it, and that's going across the open internet, you might want to have that. You might want to have that encrypted. So it kind of depends on where the traffic is going. If it's staying on your local network, you'll still probably want to have it encrypted, but you'll know that your local network is more secure than the open internet, which you just have to guarantee is not secure. Then you kind of want to understand how important are the details that are being discussed. Again, if you're talking about those multi-million-dollar business deals that are going on with, big multinational corporations, that's pretty important. You probably want to have all that encrypted. But if you're a parent, you're trying to call your kid's school and figure out what they're having for lunch, that's not really important. That wouldn't really be a bad if, some hacker spied in on your call and saw that you're calling the lunch lady and, oh, yeah, they're having chicken nuggets and tater tots for lunch today. Not a big deal. So it depends how important what you're actually discussing and who you're calling is a good way to understand which particular protocol is right. And then finally, is it important and is guaranteed delivery required? So is it okay if some packets don't always make it to the end destination? For most users, it's not a big deal because up until very, very recently, within the last year or two, almost all phone providers, either on-premise or in the cloud, have been using UDP. And not too many people have been upset and frustrated with their phone providers. So a lot of people aren't really that concerned with guaranteed delivery as a requirement. It is something important to have because it can reduce those couple times where you press your call, you press the button on your intercom and it takes 10 minutes for a call to even start ringing. That's kind of that's not good, but you can always make it better by switching over to TCP or TLS, because you'll have that guaranteed delivery, and that can take that 10 seconds for a call to connect, and turn it down to a second or 2 seconds, which is a lot more acceptable. So why is UDP being phased out in all of these different hosted systems? It's been the standard for so long. Why is it starting to get phased out? Well, anything that's sent over the open internet, you probably want to have encrypted. And with using UDP, as we now know, everything is sent unencrypted. So it's then possible to intercept all these messages. Now, when we're dealing with this, we're specifically talking about the messages that are actually setting up the call. We're not actually talking about the audio itself. We're only talking about, basically I'm calling sales, or I'm calling tech support. That's all the information that's being given out. Just who you're calling, essentially the call log is known, which is not necessarily a problem. The important part is not really who you're calling, but what you're talking about, but it's something to be concerned about. And it's something that I think, a lot of the industry has been moving towards this gradually, but they've been moving towards it just because there's a lot of security professionals and a lot of different phone system providers in their organizations and corporations, and they're moving towards actually supporting and requiring encryption as the traffic is sent in between their phone customers. But it's kind of a slow, kind of snail's pace. They didn't have a fire underneath their butt. But with everybody, getting stuck to working from home, like we all have been for the last 10 months, everybody's, working from home. More traffic is going over the internet. And as a lot of you probably saw, there was a big thing going on in the early days of the quarantine lockdown of meeting bombing. I'm not going to use the particular carrier's name, but there was meeting bombing going on where meeting credentials were given out by different students for their meetings that were occurring, and people were jumping in on those meetings and either having a laugh or potentially doing something bad. And that kind of became a little bit of a problem, and drew out it kind of put all of these different hosted providers either having a meeting or phone systems in the cloud. It kind of put this bad taste in people's mouth that, oh my gosh, I've got a phone system that's also using this particular provider. This isn't very promising for me if there's this big news scare going on, where my kids' meetings are getting leaked out and some weird people on the internet are getting in on these calls. So I think everything that's been going on with COVID in the last 10 months have actually pushed a lot more providers to push to get TLS sooner, because there's been that bad press out there just talking about how these meetings aren't particularly secure and people can get in and kind of goof off in these different classroom meetings. So that's one of the reasons that I think UDP is being phased out, but just generally, it's not the best protocol to use, especially when you're dealing with anything on the open internet. All that traffic is sent without guarantee of delivery, so that could potentially add in delay to call setup, which is something you don't expect and you don't want when you're trying to call somebody. But it's also unencrypted, so it's possible for a would-be aggressor or a potential competitor to spy on messages as they go across the open internet and figure out what's going on. They could potentially see that business deal that's going on, and they might try to finagle their way in there and get a better deal and take it out from underneath you. So those are some of the reasons why UDP is kind of being phased out with different hosted systems. So why is TCP or TLS better? Well, first and foremost, it's got that guaranteed delivery built into it. So it makes it really easy and good to know that any traffic that you're sending will make it to the end point, the end destination, because that's set up and ingrained and built in from the ground up with these particular protocols. So whatever you send is going to get where it's supposed to go, or you're just not going to be able to send it. And it can also bypass problems with basic firewalls. So it's a really good option to have in your tool bag when you're trying to troubleshoot general problems. You're trying to set up your fancy CyberData intercom that you got and you're having trouble getting it to register. Well, if you turn on TCP and it works, but it doesn't work with UDP, you know that there's probably a firewall problem going on. So it's a really easy way to be able to troubleshoot and just get an idea of what's going on. And TLS builds on top of that capability that you get with TCP by introducing the encryption, so that way you can not only guarantee that whatever you're sending is going to get to its end destination, but it's also going to get there in a way that you can have confidence in the data and nobody could potentially spy on it. So that way it builds in that kind of confidence that I know what I'm sending will get to the end destination and nobody else is going to know about it. And without the encryption keys, just because everything's encrypted, the data is literally gibberish. It's a mix of zeros and ones, and it's literally useless to anybody without those particular keys. It's gibberish. It's like trying to spy on the messages in between kids in a classroom that are coding everything with a decoder ring. I mean, heck, they even do that now. I'm not a kid anymore. But it's a really good and useful option when you're dealing with VoIP. And TLS is really the best way to go, in my personal opinion. If the provider supports it, you should use it. Just so that way you've got the confidence in your phone system that you would expect in having a local-based phone system. If you're using TLS, that nobody's going to be able to spy on your data, and it's going to get where you're trying to send it. So both of those are really good options, but I do think that TLS is the better option. So is TLS all that necessary? First of all, is TLS all that's necessary when you're dealing with secure phone calls? All that TLS does is actually encrypt the messages that are used to set up the call between the sender and the intended recipient. It actually doesn't do anything with the audio itself. The audio itself is still, funny enough, sent with UDP because it's okay for that traffic. It's okay as you're talking to somebody for a couple blips or little bits of audio to be missing in that general conversation. You'll be able to understand what people are saying if a couple packets get dropped, but it's not a big deal. But when you're dealing with TLS, you've got that security in mind. Oh, I just turned on TLS. I know that any traffic that I send is going to be encrypted. Nobody's going to be able to spy on it. Well, that's like halfway true, because while TLS is encrypting the messages to actually set up the call, it's not encrypting the most important part, what you're actually talking about. So using just TLS but not using SRTP at the same time is not particularly smart, just because, again, you're only encrypting who you're calling, not what you're talking about. So somebody could, be spying on your traffic and they could see, oh, okay, yeah, I'm seeing some unencrypted messages going between these two different IP addresses. Oh, and then here's these long streams of unencrypted, UDP messages. Let me decrypt this. Oh, I can listen to their phone call in real time because I'm picking up all this traffic and I can listen to it right now. So if you're doing TLS and thinking that your phone system is secure without doing SRTP, you're doing yourself a disservice because you're not encrypting the most important part of your call, what you're actually talking about. So then we get into audio transport options, which kind of go hand in hand again with your SIP transport options. SIP transport options just set up the call, and then RTP, or real-time protocol, or secure real-time protocol, actually get the audio from the sender to the receiver, and then vice versa. So when you're dealing with these, there's basically two options. You've either got encrypted or not encrypted. Not encrypted is RTP, and SRTP, secure real-time protocol, is encrypted. Pretty basic when we're dealing with that. So why is audio encryption important? Well, you're talking to somebody, and if you want to go the length of preventing and encrypting who you're calling, you probably also want to encrypt what you're talking about. So to talk about some of the other examples that we discussed prior, say that, multi-million-dollar business deal, multinational corporations, you spent all that time, you debugged your firewall, you got everything working properly, you turn on TLS, you select 1.2, everything's being encrypted, you give that sigh of relief, my calls are encrypted, I'm not going to have to worry about anything, I'm going to be able to set up these business deals, no problem. Well, if you're not encrypting your audio, it's all well and good. They might not know who you're calling, but they'll be able to listen and find out what you're talking about. So encrypting your audio is so important. Arguably, it's even more important than encrypting who you're calling, because that's still, that they can still kind of figure that out based on IP addresses. But having that, audio encryption and TLS for SIP message encryption really gives you that perfect combination of encrypted call setup and encrypted call audio. So of course, since everything's encrypted, it prevents spying on a phone call. And how this actually manifests, because they'll still be able to actually see the traffic if they're, actually spying on all the call that you're sending, they'll still be able to see it, and they'll be able to decode it and say, oh, this is an audio stream, and they'll listen to it, and it'll it'll just sound like white noise. For anybody that doesn't know what white noise is, it's that sound when you would turn on your old, I don't think you can get this anymore today with, your fancy LCD or your plasma TVs, but back in the old days, and you had your cable box and you turn on your TV and you would get static. That's what white noise is, and that's how your calls will sound if your audio is actually encrypted. You literally just get static. And that way, there's no way that they could kind of filter through the static and get an idea. The data is completely useless in that audio traffic without the encryption keys. So this ensures private conversations stay private. So in that scenario where we're talking about, that multi-million dollar business deal, that private conversation that you want to keep private as you're talking about these different, okay, you give us this plant, we'll give you that plant, whatever you guys are talking about. All of that can stay encrypted and that conversation stays private. So when you're dealing with this audio encryption, again, you want to decide if what I'm talking about and where the traffic is going, if it's important to actually encrypt it. If you have the capability to encrypt it, do it, because it's better to have it encrypted when you don't need it than want it encrypted when you don't have it encrypted. But if anything's going to be on your local network, say, you're just at, you're kind of Joe Schmo pencil pusher and you're trying to call your boss because he wants those TPP reports. He wants those turned in. You found out they were late. You got that memo and you got to turn in those TPP reports and you call your boss. And if that's all staying on the local network, nothing's going outside of the network, you don't necessarily have to have that encrypted because it's staying on your local network and you've got reasonable amounts of confidence that your local network is secure. By no means take that as a recommendation that means, okay, any traffic on my local network shouldn't be encrypted. It should, because you should always encrypt traffic if you can. But if it's on your local network, you've got that reasonable confidence. It's like basically staying in your own home. You've got that reasonable confidence for it to be secure there. But once it goes to the open internet, once it goes to that outside world, you don't have that reasonable confidence that, okay, just because it's going outside, there's a possibility that somebody could spy on it. So when you're dealing with any potential audio encryption, it's always better if you have the options to do it, but it's not always necessary if you're going to be dealing with stuff on your local network. For the most secure phone calls, you're going to want to combine TLS and Srtp. So that means messages sent to start the call are encrypted, and then the audio after the call setup is also encrypted. So that means that the call setup and the actual call itself are completely encrypted, so that way only point A and point B know what's going on. Anybody that intercepts that traffic has no idea what's being discussed and who's discussing it. So these are really good options when you're dealing with a hosted VoIP provider, again, because as the data goes across that open network and that open internet, a would-be aggressor and a would-be spy, they don't have anything good. They've just got, junk. So it's really, really useful and a great idea if you want those secure phone calls to enable TLS and Srtp. A lot of hosted providers actually already require this. Some support it but don't require it, but a lot of them already require it. So it's really good depending on your hosted provider. You've probably already got TLS and Srtp as requirements. You don't have to worry about it. And this whole presentation has probably been pointless for you, but maybe a little informative, but you've probably already got that. And a lot of hosted providers are starting to switch to recommend and then soon to require TLS and Srtp for their calls. So that way they know that all of their customers can have the confidence that what they're calling about stays encrypted and stays private. So it's going to become more and more an industry standard as time goes on, and especially with more people switching and transitioning to working from home permanently, especially after the quarantine. People might just start working at home permanently just because it's more accessible and easier for everybody. So I think more and more we're going to get a lot more hosted providers to support and require TLS and Srtp, and I think it will eventually overtake UDP and regular RTP being the industry standard. I really think TLS and Srtp are going to be the standard for pretty much all VoIP phone traffic in the next couple of years. It's not as important, again, when you're dealing with that local phone system. If all of the call traffic is staying within your local network and you've got confidence in your local network that your local network is secure, It's not as important to have everything encrypted. You still should, but it's not as important as something that's going to be going across the open internet. So do I need TLS and SRTP? Really, at the end of the day, it kind of depends on what you're talking about on your phone system. If you've got people that are doing big business deals that, potentially talking about sensitive information with clients or dealing with, a law office, that type of stuff, you probably want to have everything encrypted, who you're calling and what you're calling about. But if, you're a small auto mechanic shop and you're not really dealing with anything, secure, is my car ready? Oh, no, we had to order some parts and your car will be ready in a day or two. We'll give you a call. Not super important for that to be encrypted. You can encrypt it and you should encrypt it, but it depends what's being discussed on your phone system if you really need TLS and SRTP. It's always recommended, but it's not necessarily required. And then the next kind of reasoning and idea for it is your system, of course, going to be either local or is it going to be hosted? And if you're, again, dealing with any traffic that goes across the open internet, you probably want it encrypted. And depending on how confident you are in the network security you have on your local network, you might want it to be encrypted, you might not. I recommend having it encrypted, but you don't have to. And then if the system is hosted, TLS and SRTP are almost always a good idea. If your provider supports it, I would really recommend enabling it, just so that way you've got that confidence to know that if somebody does try to spy on our calls, they're not going to be able to get anything out of it. But some of the downsides that a lot of people start to encounter as the industry moves towards requiring TLS and SRTP is not all products support TLS and SRTP for that matter. There are a lot of, unfortunately, CyberData products, especially a lot of our, let's say, our V2 speakers in particular are really going to be impacted as a lot of providers switch over to requiring TLS and SRTP. So it's really one thing to consider as you're going and migrating to other providers is what hardware you currently have. If you're going to be migrating that hardware over to a different provider, is what does this equipment support? Does that investment in $10,000 in speakers still support that TLS or SRTP as I migrate to a hosted provider? If it doesn't, it's probably time to look for either an option to facilitate paging in a different manner. Say one of our SIP paging servers that can send multicast to those old V2 speakers and have your V2 speakers not register with your phone system. So that way all of the traffic could be sent in between a device that has that capable encryption, and then that device with the capable for encryption with that TLS and SRTP can send multicast back across the local network to continue to utilize that investment in those old V2 speakers. But that's going to be a thing to consider as a lot more providers are switching over to TLS and SRTP, is what products you have and do they support these new features. So as we get to the end of our presentation today, I'd like to go over just the index of terms and stuff that we talked about. We did define all of these terms already, but I always like to go over them again as kind of a closing. We've got SIP, which is one that you'll definitely hear a lot of, especially at CyberData. We call all of our products SIP outdoor intercom, SIP outdoor intercom with keypads, so on and so forth. So if you're a CyberData customer, you've got this one drilled in your head. And SIP is Session Initiation Protocol. Then we've got UDP, very common protocol that's used. This is User Datagram Protocol, probably the most used protocol on the internet. Then we've got TCP, Transport Control Protocol, which is just another way to guarantee delivery from A to B, just another way to make sure it's going to get there. You've got TLS, which is just encrypted TCP, known as Transport Layer Security. And then we've got RTP, your audio transport, real-time protocol, and SRTP, your secure audio transport, and that secure real-time protocol.
Thank you for watching this edition of CyberSchool. If you have any questions, please get in contact with our sales department. They are available by email at sales@cyberdata.net or by phone at 831-373-2601 extension 334. Please make sure to like this video and subscribe for more content like this from CyberData.